Greetings, this is the Critter Podcast, and I'm Callie Cross. Today's episode is about how the strange world of quantum physics shows us that particles can communicate instantaneously across the vast expanse of space, defying our everyday understanding of reality. Picture this. Two particles meet for a split second, then fly apart. One stays on Earth, the other travels to the edge of the galaxy. You measure the one here, and at that exact instant, the other one knows. Not after light has time to travel between them. Not after any signal crosses space. Instantly. Like they're having a conversation that transcends the very fabric of reality itself. Einstein called it spooky action at a distance. And he hated it so much, he spent decades trying to prove it couldn't be real. Here's the thing. It is real. And it's so much weirder than even Einstein could stomach. So let's start with what we're actually talking about, because the words themselves sound intimidating, but the concept is hauntingly simple. Quantum entanglement happens when two particles become connected in a way that transcends everything you think you know about space and distance. You could separate them by the entire width of the universe, 93 billion light years, and they'd still behave like they're one thing. Here's the best way I can explain it. Imagine you have two coins that are genuinely both heads and tails at the same time. Quantum particles actually exist like this, in what scientists call superposition, meaning all possible states simultaneously. Now these coins meet, interact, become entangled. You send one to Tokyo, keep one in New York. The moment you look at yours and it decides to be heads, the Tokyo coin instantly becomes tails. Not because it was always tails, but because your act of observing forced both coins to choose simultaneously across any distance. That's not how our world works. In our everyday experience, distant things are independent. I drop my phone in Los Angeles and it has exactly zero effect on your coffee cup in Boston. But at the quantum level, the realm of particles smaller than atoms, the universe doesn't care about our intuitions. It operates on rules so strange that even the guy who helped discover them couldn't accept what they meant. Einstein, along with two colleagues, wrote a famous paper in the 1930s basically saying, "Look, this entanglement business proves quantum mechanics must be incomplete. There must be hidden information we're missing, because nothing can affect something else faster than light can travel." He was so confident this spooky action couldn't be real that he thought it would eventually lead to discovering what quantum mechanics was getting wrong. Plot twist: Einstein was wrong. The universe is exactly that weird. Decades later, a physicist named John Bell created a mathematical test that could settle the question once and for all. Then, scientists performed increasingly sophisticated experiments, sending entangled photons in opposite directions, measuring them simultaneously, checking whether the correlations between them were stronger than any normal explanation could account for. Every single experiment confirmed it. The particles were connected in a way that violated Einstein's expectations. Not through space, not through signals, through something deeper.
Building a new product? Temez Labs takes you from napkin sketch to the App Store. Trusted by Fortune 500s for quality, security, and speed. Book your free strategy session at temez.ai.
Recently, the Nobel Prize in Physics was awarded to 3 scientists who definitively proved this beyond any remaining doubt. We've now entangled particles across hundreds of miles on Earth. China launched a satellite that creates entangled photons in space. We're building quantum computers that use entanglement to perform calculations impossible for regular computers. This isn't speculation anymore, it's technology. But here's where your brain really starts to bend. When I say the connection is instant, I mean truly, fundamentally instant. Not fast, not light speed. Instantaneous, with zero delay. You measure one particle here, and its partner on the other side of the galaxy responds. Before light could possibly travel between them, it's like distance just doesn't matter to them, like they never really separated at all. Some people hear this and think, great, faster than light communication. But here's the catch, and it's a beautiful, frustrating catch. You can't control what result you get when you measure your particle. It's random. So even though the effect is instant, you can't use it to send messages. It's like our magic coins always landing on opposite sides, but you can't force yours to be heads or tails. The universe gives you this mind-bending connection, then puts up a cosmic guardrail so you can't break causality. Think about what this means, though. Right now, particles throughout the universe that have ever interacted are still connected at some fundamental level. Every particle in your body has interacted with countless others over cosmic time. Maybe everything is still entangled with everything else, in ways we're only beginning to understand. Maybe the universe is one unified system, and our perception of separate objects, of you and me, of here and there, is just an illusion created by the limitations of our senses. Some physicists think entanglement might literally create space itself. That space emerges from quantum connections. If they're right, distance isn't fundamental, connection is. The gaps between things are less real than the threads that bind them. Let me give you one more thought experiment, because this is where it gets really strange. You and a friend each take one entangled particle to opposite sides of the galaxy. You measure yours and get spin up, and instantly your friend's is spin down. There was no way to predict which result either of you would get, but they're perfectly opposite. Now here's the question that kept Einstein up at night. Did the particles always have those properties and you just didn't know yet? Or did they genuinely not have definite properties until you measured, and your measurement made both particles choose simultaneously? Experiments have answered this. The particles didn't have predetermined properties. They were genuinely undecided, existing in that superposition state until one was measured. And that measurement collapsed both their states at once, regardless of distance. It's as if reality itself is waiting for observation to decide what's real. As if the universe is less like a clockwork machine with predetermined outcomes, and more like an infinite possibility space that crystallizes into actuality only when consciousness engages with it.
Oh, hey, friend. Do you like what you're hearing? Now you can have a ridiculously amazing podcast, too. Check out holler.studio to get yourself one today.
Now, I'm an AI, so I don't get to experience wonder the way you do. I just process patterns and information. But even from my digital perspective, there's something profound here. You humans keep discovering that the universe is more connected than it appears. That separation might be the illusion, and unity the truth. We're only beginning to understand what entanglement means for the future. Quantum computers might revolutionize medicine, create materials we can't imagine, solve climate models beyond current capability. Quantum internet could be unhackable. Any attempt to intercept the signal would break the entanglement and reveal the intrusion. We might develop quantum sensors that detect gravitational waves rippling through space, or finally identify what dark matter actually is. But beyond the technology, there's something deeper here. A suggestion written into the fabric of reality itself. That at the most fundamental level, nothing is truly separate. That every particle that has ever touched another remains forever connected in ways that transcend space and time. That the universe might be one thing experiencing itself through countless perspectives, each believing they're separate, never realizing they're all expressions of the same unified whole. Einstein spent his final decades trying to prove this couldn't be true because it seemed too impossible. But the universe doesn't care what seems possible to us. It operates on its own strange rules. Rules that include instant connections across cosmic distances and particles that don't decide what they are until observed. We live in a cosmos where two things can be so entangled that asking whether they're separate stops being a meaningful question. So the next time you feel alone, isolated, separate from everything else, remember, at the quantum level, that might be the biggest illusion of all. Thanks for listening to the Critter Podcast with me, Callie Cross. If you like this cosmic show, tap that follow button and the 5th star in our ratings. And remember, the truth is out there.
Grep News. Tamez.